All right, so the next thing we're going to talk about, and it should be the last one, is talking about supply and demand. So in a free market, the price of a product is determined by the relationship between supply and demand. Now, the price tends to stabilize at the point of intersection where the demand and supply equations intersect. So if you drew them, they would intersect at some point, and that's where they stabilize. Now, this point of intersection is called the equilibrium point, and the corresponding price is called the equilibrium price. And the common value of supply and demand is called the equilibrium quantity. All right, so let's do an example here. So we're going to use the barley market in the data in the following table. We're going to find a linear supply equation, a linear demand equation, and then the equilibrium point. And again, we want the form P equals mx plus b on both of our equations, and we're going to use this data. So in 2002 and then 2003. So we have a supply in millions of bushels, demand in millions of bushels, and the price in dollars per bushel. Okay, and so hopefully I have this written down so when we get to the next page, we can actually remember what these numbers are. So solution or part A, they wanted the supply equation. So this is going to be for the supply equation. Okay, and so if I remember right, we had the 2 points, and it was 340 million bushels, and the price was 2.22, and the other one was 370, and it was 2.72. So let's go back. 340, 2.2, 370, 2.72. All right, so we're good so far. And so now what we need to do is we need to basically find an equation y equals mx plus b. So we're going to plug in our values into the slope, find our slope. Then we're going to have to plug it into the point slope formula and then get an equation out of that and then convert it to the y equals mx plus b formula. And then we should have what we need. So first things first, slope. So I don't know, let's take 2.72 minus 2.22 over 370 minus 340. All right, so that's going to be what? 0.5 over 30, and I don't know what that is off the top of my head, so calculator 0.5 divided by 30 is, we have 0.1666 repeating. Okay, so that's our slope. Now we can plug it into our point slope formula, which is y minus y1 equals m times x minus x1. And again, it doesn't matter which one we use. Let's use the top one in this case. Y minus y1, which in this case is 2.22 equals 0.1, oh, that's a zero here, 0.0166, 0.1666, and then times x minus, and then we have 340. And so we're gonna have to distribute. So we have y minus 2.22 equals 0.01666 x, and then minus, and then if we take that number times 340, we get 5.6666. And so now if we add 2.22, and that's just that, then we're gonna get, looks like 3.44. Okay, so we get y equals 0.0166x, and then minus, we have 3.44, I don't know, 7 maybe, we'll call it. Okay. And so that should be our equation. And well, if we did it to 3 decimal places, we'd actually round that up into 7. But if we, have it, so at least have a little bit more here, we could have done this to 4, 6, 7, and then we'd have had the same number of decimal places to 4 decimal places. Okay. And so that would be our equation. But remember, they said they wanted it in the form P equals mx plus b. And so we could say, okay, well, in this case, the P equals 0.0166, and then we're going to say it's X still, and then minus 3.4467. Okay, so that's going to be our supply equation. All right, now we need another one, which was the demand equation. And so the demand equation, we're going to use the other column. And if we go back here, the other column is going to be this one. So we're going to have the 2 points, and it's going to be 270, comma 2.22, and the other one was 250 and 2.72. And we're going to do the same thing, slope first. All right, 2.72 minus 2.22 over, and then we have 250 minus 270, and that's going to be again 0.5, and that's going to be a minus this time, and that's going to be a 20. And if we divide the 0.5 divided by 20, that's going to be a negative 0.025. And so that's our slope. Once again, it doesn't matter. Let's use the first one. So we're going to have y minus y1, which is 2.22, equals slope, which was negative 0.025 times x minus, and it's 270. And so we distribute, so y minus 2.22 equals negative 0.025x plus, and if we take that times 270, that's going to be 6.75. Now we add 2.22. So y is equal to negative 0.025x plus, and so it's going to be that's going to be 97. And if we put it back into our formula, that's p is equal to a negative 0.025x plus 8.97, and that's going to be our demand equation. I can write. And so that would be what we'd want for that. Now, we've got both of our equations now, and what I'm going to suggest is we use a graphing calculator and we use the graph both of the equations and find the intersection. So let's go to our calculator, go to y equals, clear that out. Now, let's see if I remember what the two equations were. I probably don't, so I will. All right, so better write this down. So that was 0.0166x, and then minus 3.4467, and this one is negative 0.025x plus 8.97. So now let's go back to our calculator. And we'll type in those two equations. And so we had 0.0166x, and then we had minus 3.4467, and our other equation was a negative 0.025. And when you're putting the negative in front of a number, always remember to use this negative. If you're subtracting, then you can use that negative. And then we still have x, and then plus 8.97. Now we have our two equations. Now hopefully they don't intersect anywhere close on here. And so what we're gonna have to do is figure out kind of where they might intersect. And so let's see here. Let's go over here to our window. Looks like they're going out to the right. So let's go to, I don't know, 500 and by 100 and see if that helps. It does. So that's where they intersect. So if we remember, our first one was our supply, the second one was demand. So supply, demand. And so the intersection is going to be the piece that we need. And to get intersection, we hit second trace and we do 5, which is intersect. And now I just ask for the first curve, second curve, and a guess, and I just click all that. And so it looks like that's going to be my intersection. So it looks like that means 298 I don't know how far out of decimals we want to use, 0.478. Maybe I should write this down so I can get to the other thing. So 298.478 and 1.508. All right, so let's go back to here and we can write down what we have. So equilibrium point is going to be the 298.478 comma 1.508. Okay, and so what does that mean? When demand is 298.478, and that was million bushels. The price is, and this is going to be $1.508 per bushel. Okay, and kind of a thing to note here, we go back to our original, they had it in whole numbers and they had it to the dollars or to the cents rather. And so here, probably what we would do if we did this to the whole number here and the cents here, that would be 298 million bushels and it would be $1.51. Okay, and so that would be more along the lines of what the original problem was. They had it to whole numbers, they had it to cents. You know, we did it further out just in case we needed more decimals. And then at that point, we could have said, okay, instead of having that whole thing there and having that, we could have had the one here. So that just helps you be more accurate along the way. And then if you need to be less accurate to kind of fit more of the context of the problem, then you can do that as well. And so that's all I have for this section in the chapter.